Okay, so I'm going to find the inverse function of 4x plus 1. So the inverse function is noted as f to the minus 1 of x. So I'm going to first of all bring in y and x notation here, so y equals 4x plus 1. To find the inverse function, I then swap my x's and y's. So x equals 4y plus 1. I then need to change the subject of the formula to y. So 4y plus 1 is equal to x. 4y equals x minus 1. And y is equal to x minus 1 over 4. I then reintroduce the functional notation. F to the minus 1 of x is equal to x minus 1 over 4. And x minus 1 over 4 is the inverse function to 4x plus 1. Let's try another one. So f of x equals x squared minus 3. And I'm looking for the inverse function. So change to y and x notation. Y equals x squared minus 3. Swap the variables. So x equals y squared minus 3. And then change the subject of the formula to y. So that'll be y squared minus 3 is equal to x. Y squared is equal to x plus 3. And y is equal to the square root of x plus 3. Reintroduce the functional notation. And f to the minus 1 of x is equal to the square root of x plus 3. Okay, f of x equals x cubed minus 3. So introduce the y and x notation. Y equals x cubed minus 3. Swap the variables. X equals y cubed minus 3. Change the subject of the formula to y. So y cubed minus 3 is equal to x. Y equals x plus 3, or y cubed is equal to x plus 3. And then y is equal to the cube root of x plus 3. Reintroduce the functional notation. F to the minus 1 of x is equal to the cube root of x plus 3. Final one, f of x equals x over 4 plus 7. So bring in y and x notation. Y equals x over 4 plus 7. Swap the variables. X equals y over 4 plus 7 and change the subject of the formula to y. Y over 4 plus 7 is equal to x. Y over 4 is equal to x minus 7. And y is equal to 4 bracket x minus 7, which I can then expand out 4x minus 28. And rewrite with functional notation. F to the minus 1x equals 4x minus 28.